This is Ms. Humbert here, and today we're going to be doing Unit 9, Notes 3. So we're going to be talking about simplifying rational expressions. So we want to basically be simplifying them down as well as finding the excluded values. And we'll talk about what excluded values are in a second. So first of all, what is a rational expression? A rational expression is an algebraic fraction whose numerator and denominator are polynomials. So that means there's letters, exponents, coefficients, all that stuff you learned about in Unit 3. What is an excluded value? An excluded value is any value that makes the denominator of the rational expression 0. Now we need to exclude those values because the denominator of a fraction cannot be 0. That is a huge math no-no. Okay, and finally, if the denominator is a quadratic, here's how you're going to find those excluded values. You're going to factor and use the zero product property. If the denominator is monomial, each variable can't be equal to 0. So those are kind of the processes you're going to use while working through this. So let's start by taking a look at examples of how to find the excluded values. So to find the excluded values, all you have to do is set the denominator equal to 0. So I'm going to take m minus 6 and I'm going to set it equal to 0. So then I'm going to go ahead and I'm going to add 6 to both sides, and I get that m cannot equal 6. Because remember, when we solve the denominator, that's what we don't want the denominator to be. So we put the slash through the equal sign to indicate that's what it can't be. Taking a look at this next one, this bottom cannot equal 0. X squared minus 5x plus 6. So we need to do some factoring. So we're going to do 6 and negative 5. So I have a positive product and a negative sum. So that means both my signs are negative. So I have negative 3 and negative 2. So remember what I talked about in the previous note sheet, that if this number is 1, which it is here, you can immediately put it in the factors. And that's just to save you some time. If you don't feel like you're comfortable doing that and you still want to use the grouping method, feel free. So now is when I'm going to use a zero product property. And I don't want these to equal 0. So I'm going to set each of those factors to not equal 0. So then we get that x cannot equal 3 or 2 when you solve each of those equations. Let's take a look at number 3. So for number 3, we want to set 3x equal to 0. So 3x equals 0. Well, divide both sides by 3. And 0 divided by 3 is just going to be 0. So you get that x cannot equal 0. So sometimes I write excluded value next to it just to remind myself that that's the excluded value when I get to doing a lot of work. Okay? All right, so let's take a look at number 4. Now, number 4 seems like it'd be really tricky, but it's actually not that bad. So we're going to set our denominator so that it doesn't equal 0. So 4x squared y to the 5th is equal to 0. So we don't want that to equal 0. So what I do is I take and I set each part equal to 0. Well, 4 equals 0, that doesn't even make sense. That's never going to happen. So then I ask myself, okay, when is x squared going to be equal to 0? Well, remember that x squared is really the same as x times x. And the only way you can multiply to 0 is if you multiply by 0. So we know that x cannot be equal to this here. Or to 0, sorry. Same thing here is that y to the 5th, that's the same as y times y times y times y times y. And when you multiply 5 y's together, the only way that that cannot be 0 is if y isn't 0. So whenever you have just a variable to an exponent, the variable cannot be 0. So that's kind of a trick you can use as you're going through this. So let's take a look at simplifying rational expressions. So we want to eliminate any common factors in the numerator and the denominator. So that's kind of our goal. We're trying to put it in a more simplistic form. So let's go ahead and let's take a look at doing this. Let's actually start applying it. Oops, or we could just skip 5 and 6. That's cool too. So what I like to start off first with is just simply reducing the fraction. So here I have 32 divided by 4. So 32 divided by 4, well, that's going to give me 8. Then I want to use my rules of exponents. So I see here that I have x to the 5th divided by x to the 1st. Well, when I have x to the 5th divided by x to the 1st, the best way to get rid of that is to subtract the exponents. So that's going to end up giving me x to the 4th on top. Then I have y squared divided by y to the 7th, and when you subtract those out, you're going to end up getting y to the 5th, and that y to the 5th needs to go on the bottom because the larger amount of y's are on the bottom. So now this is my simplified form. Cool. I need to find my excluded value. However, when I go to find my excluded value, I need to start from the original denominator, not my simplified denominator, the original denominator. So I'm going to take a look at 4xy to the 7th, and I know that that can't be equal to 0. Well, I have two things that are raised to an exponent being multiplied. So that means that for my excluded values, x cannot be 0 and y cannot be 0 for those excluded values. Okay? Let's take a look at number 6. So for number 6, we have 16 divided by 8. That's going to give us 2. Then I have c squared divided by c to the third. Well, we're going to end up with c to the first when you subtract those out. And that c to the first is going to be on the bottom because that's where your larger amount of c's are. Then Caesar, that sounded like Caesar. Sorry. Okay. Anyway, b to the fourth divided by b to the first. Subtract those exponents and you're going to get b to the third. And again, that's going to go on top because that's where your larger amount of x's are. Now remember that when you have a variable such as c to the first, you actually don't have to write c to the first. You can just write that as c. So let's kind of do a check. Think back to your simplified monomial list. Are all fractions reduced? Yes. Are there no powers of powers? No. Are all like bases combined? Yes. So that is my simplified rational expression, which really is just dividing monomials like you did in Unit 3. The extra step now is calculating out that excluded value. Now remember that the excluded value calculation has to come from up there. So we have 8c cubed b is not equal to 0. So c cubed is not equal to 0. And b is not equal to 0. Well, the only way c cubed is going to be equal to 0 is if c is equal to 0. So my excluded values are that c is not equal to 0 and that b is not equal to 0. And that's your answer for number 6. All right, let's take a look at number 7. So in order for us to simplify this, we have to do some factoring. And one of the things students forget the most is that 7, that 3x minus 15, can be simplified. Students forget that greatest common factor is a form of factoring. So you can take a 3 out of each, and when you divide each term by 3, you're left with x minus 5. Then on the bottom, when you set up the x, we're multiplying to 10 and adding to negative 7. So that's going to be negative 5 and negative 2 because we have a positive product and a negative sum. Again, notice that this coefficient is 1. So I can immediately write out my factors directly from the x. Cool, right? Pretty sweet. So then, what I want to do is I want to cross off any factors that are overlapping. You can cross off factors if and only if they're being multiplied. So if I had some factors being added, I couldn't do this, but if you'll notice, this factor here is being multiplied by this factor here. So I can go ahead and I can cancel out those x minus 5s. And then left on top is 3, and on the bottom is x minus 2. So this right here is your simplified radical. So then, what I want to do is I want to, again, take a look at my original denominator. Well, this right here is the factored form of my original denominator. So I'm going to use that, and I'm going to set that equal to 0 because that's going to be easier for me to solve because now I can use the zero product property to find my excluded values. So x minus 5 cannot equal 0, and x minus 2 cannot equal 0. So that means that x cannot equal 5 or 2 for your final answers, your excluded values for number 7. Now let's take a look at number 8. Number 8 is going to require 2 rounds of factoring. So we're going to be multiplying to a negative 35 and adding to a negative 2, and we're going to be multiplying to 14 and adding to a negative 9. So to set up this x, I'm going to use negative 7 and 5. To set up this x, negative 7, negative 2. Now I'm going through the setup of the x pretty quickly because you learned that already in Algebra A. If you are struggling, please either talk to me in class or please look at the folders. Unit 4 folders have all the videos that talk through how to do this if you think that would help you as well. So let's go ahead and let's take a look at our factors. So again, for both of these, our coefficient with the squared term is 1. So we can instantly write it in factored form. Factored form on top, please. Please give me factored form. There we go. And factored form on the bottom. So you'll notice that both have factors of x minus 2. So I can go ahead and cancel those guys out. And then left, I have x plus 5 divided by x minus 2. And you don't have to write the parentheses. You could simply write x plus 5 and x minus 2. Now here's a mistake students try to make. They try and cancel out those two x's. You can't do that because there's addition involved without multiplication. So that has to stay exactly as is. You can't cancel out those x's. So that's your final answer for number 7. Now we need to find our excluded values. So again, to calculate our excluded values, I'm going to look at my original denominator when it's in factored form. So I'm saying x minus 7 times x minus 2 cannot be 0. So then x minus 7 is not 0. X minus 2 is not 0. So then I get x cannot be 7 or 2 for your excluded values. All right, let's take a look at this word problem. So define a variable for neon fish and guppies. So I'm going to use N for neon fish and G for guppies. Then write an expression that represents the fraction of neon fish in the aquarium. So Jenna has guppies in her aquarium. 1 week later, she adds 4 neon fish. Okay, so we want to figure out how many the ratio of neon fish. So basically what we need to have is the number of neon fish divided by the total number of fish. Well, here's what we know. We know that there's 4 neon fish, so I actually don't even need to use my N because I know there's 4 neon fish. So the total of number of neon fish is 4. Then, on the bottom, the total number of fish is our number of neon fish plus our number of guppies. But we don't know our number of guppies. So what I'm going to do is I'm going to use G to represent our number of guppies and then add 4 neon fish. So that's your final answer for part A. Excuse me. Okay, so let's take a look at part B. Suppose 2 months later the population of guppies doubles. So to represent doubles, that's just we're going to take our guppy population and we're going to multiply it by 2. Jenna still has 4 neons and she buys 5 tropical fish. Write an expression that shows the fraction of neons. So she still has 4 neons. Remember, our fraction is going to be neon over total. Now our total is going to change. We have a doubled guppy population, which is 2G, and then we have 4 neon fish, and we added 5 tropical fish. So then we just need to simplify this out some more. So we have 4 divided by 2G plus 9, and that's your simplified expression. Now recall on problems like this, you can't simplify out the 4 because there's that addition symbol in the middle. So for both of this is your final answer. So that concludes your note video for today. Please make sure you get that Schoology quiz taken once you are done. Thank you for listening.